Hi everyone, today we are going to revise chapter 10, carboxylic acid and its derivative. Carboxylic acids are organic compounds containing the carboxyl group COOH. There are three representations of a carboxylic acid, which are shown below. The common names of some carboxylic acids are derived from Latin names that indicate the first original natural source of the carboxylic acid. For example, methanoic acid is known as formic acid, ethanoic acid is known as acetic acid, while propanoic acid is known as propionic acid. Butanoic acid common names is butyric acid. For systematic nomenclature of substituted carboxylic acid, first we need to identify the parent chain that contains all the carboxyl group if there are more than one carboxyl group. Second, number the parent chain from the carbon of the carboxyl group. Third, identify the substituent and assign each substituent a locator or address number consistent with the numbering in the parent chain. And lastly, arrange all the name of the substituent in alphabetical order in the systematic name of the polysubstituted carboxylic acid. Here are some examples for the IUPAC nomenclature of carboxylic acid. For example, this is the simplest carboxylic acid which contains only one carbon. Therefore, the IUPAC nomenclature is methanoic acid. And for the second example, there are two carbon and we must number from the carboxyl group as first carbon. Therefore, the IUPAC name is ethanoic acid. And carboxyl group is at the carbon chain. The longest carbon chain here is 3 carbon, while there is a benzene ring at the second carbon. IUPAC name is 2-phenyl propanoic acid. The fourth example, here got 2 carboxyl group which is at both ends of the carbon chain, and the longest carbon chain is 3 carbon. Therefore, it is propane dioic acid. For the last example, the longest carbon chain is 5 carbon and the cyclohexane group is at the 4th carbon. Therefore, it is named as 4-cyclohexyl pentanoic acid. For substituted carboxylic acid with the carboxyl group attached directly to a ring, the carbon of the carboxyl group is itself not numbered, but it is by conversion taken to be attached to carbon number 1 of the ring. For this example, the carboxyl group will not be given any number, but the number will be given to the ring that attach to carboxyl group as number 1 and number 2 like this. Therefore, the IUPAC name is 2-methyl cyclohexane carboxylic acid. Same thing occur to this example. The carbon of carboxyl group will not be given as carbon number 1, but the carbon in the ring that attach directly to the carboxyl group will be numbered as number 1. The IUPAC name of this structure is 1-chloro-2-methyl cyclopentane carboxylic acid. Substituted aromatic acid with one carboxyl group are named as derivative of benzoic acid, with the position of the substituent being cited using the locator according to their position on the benzene ring relative to the carboxyl group. The carbon on which the carboxyl group is attached is by C1. This is same as previous example. When the carboxyl group is attached to the benzene ring, the carbon in the benzene ring will be numbered as carbon number 1. This IUPAC name is 4-hydroxy-2-methyl benzoic acid, while the second structure IUPAC name is 2-nitrobenzoic acid. Now we are going to discuss the physical properties of carboxylic acid. For boiling point, here is the graph that shows the increasing order of boiling point. As what we know, carboxylic acid, alcohol and amines, all these three compounds can form hydrogen bond between molecules. Therefore, they should have higher boiling point compared to the rest of the compound. The reason why carboxylic acid has highest boiling point is due to carboxylic acid can form stable hydrogen bonded dimer, which has a stronger hydrogen bond, more energy required to overcome the stronger hydrogen bond. Therefore, the boiling point is higher. Comparison between alcohol and amine. Alcohol has higher boiling point than amine. Reason is because oxygen is more electronegative than nitrogen. Hydrogen bond between alcohol molecule is stronger than between amines molecule. Since carboxyl group, hydroxyl and amino group can form hydrogen bond between molecule, therefore more carboxyl, hydroxyl and amino group can form more hydrogen bond. It will be has higher boiling point. Aldehyde, ketone, haloalkane are polar molecule, so they have stronger dipole-dipole forces if compared to alkane, alkene. Those are nonpolar molecule with weaker London forces, and this factor only apply when they have similar molecular size. For solubility in water, carboxylic acid is the highest solubility than alcohol and amines. Carboxylic acid can form more hydrogen bond with water molecule, therefore it has higher solubility. While alcohol will have higher solubility than amine, is due to oxygen is more electronegative than nitrogen atom. The hydrogen bond between alcohol molecule with water is stronger than hydrogen bond between amines with water molecule. The molecule with more carboxyl, hydroxyl, and amino group can form more hydrogen bond with water molecule, therefore the molecule will have higher solubility. While the rest of the compound cannot form hydrogen bond with water molecule, they only has weak van der Waals forces with water molecule, therefore the solubility of this compound will be lower. Alkyl group is hydrophobic area. The larger the alkyl group, the lower the solubility in water. Now we discuss about acidity between carboxylic acid, phenol, and aliphatic alcohol. Carboxylic acid has higher acidity if compared to phenol and aliphatic alcohol due to carboxylic ion is more stable than phenoxide ion. Oxygen is more electronegative than carbon atom. The negative charge is delocalized between two oxygen atoms in carboxylate ion is more stable than delocalized into the benzene ring between oxygen and carbon atom in the phenoxide ion. While aliphatic alcohol has lowest acidity due to alkoxide ion cannot delocalize the negative charge, cannot stabilize by resonance structure, or we also can mention alkyl group is electron donating group which destabilize the alkoxide ion by increase the electron density at the oxygen ion. Other than that, inductive effect also will affect acidity. Inductive effect caused by electron withdrawing group will stabilize the negative charge on oxygen atom, which will increase the acidity, while inductive effect caused by electron donating group will destabilize the negative charge on oxygen atom and thus decrease the acidity. Position of electron withdrawing group is closer to the carboxyl group, or the molecule with more electron withdrawing group will increase the acidity due to the position and the number of electron withdrawing group. Now we're going to discuss the question about acidity. Arrange the following compound in descending order of acidity. Explain your answer. Phenol, cyclohexanol, benzoic acid, 4-nitrophenol. This question will be given 5 marks. So the answer is benzoic acid is higher acidity compared to 4-nitrophenol, followed by phenol and followed by cyclohexanol. Reason is benzoate ion is most stable since the negative charge is dispersed or delocalized on two more electronegative oxygen atoms, while nitrophenoxide and phenoxide are less stable than benzoate ion since the negative charge is dispersed on one oxygen atom and less electronegative carbon atoms. Phenoxide ion is less stable than nitrophenoxide ion since it has no electron withdrawing group, the nitro group, which stabilizes the phenoxide ion. For cyclohexanol, the alkoxide ion is the least stable since the negative charge is localized on one oxygen atom only. Now we are going to revise the preparation and chemical properties of carboxylic acid. There are 3 methods to prepare aliphatic carboxylic acid, which are hydrolysis of nitrile compound. Second is oxidation of primary alcohol by using strong oxidizing agent. And the last is oxidizing of aldehyde. Primary alcohol also can oxidize become aldehyde by using weak oxidizing agents such as PCC in CH2Cl2. Now we are going for chemical reaction of carboxylic acid. Carboxylic acid can react with base to form a salt. For example, very strong base Na, strong base NaOH, or weak base NaHCO3. All these will form the same type of salt. If carboxylic acid react with magnesium or calcium, then we also will form salt ionic compound, and then if we are using calcium, then this part will become Ca2+. Reduction of carboxylic acid will form primary alcohol. Esterification of carboxylic acid with alcohol with the presence of acid as catalyst, then it will form ester. Carboxylic acid react with ammonia will form primary amide. React with primary amines will form secondary amide, while react with secondary amide amines will form tertiary amine. Carboxylic acid will react with carboxylic acid in the presence of P2O5 heated will form anhydride molecule. Based on the reaction scheme in figure 1, draw the structures of K, L, M, N, and P. Reactants is M-methyl benzoic acid. So the structure is like this. This is the structure of M-methyl benzoic acid. When M-methyl benzoic acid undergo oxidation with sodium dichromate, the methyl group at meta position will be oxidized become carboxyl group. Therefore, the structure will be like this. Reduction of M-methyl benzoic acid, the carboxyl group will undergo reduction to form a primary alcohol. Therefore, the structure of L is this. M-methyl benzoic acid react with ethane amine. It will form a secondary amine. So the carboxyl group will react with amino group to form amide groups. M-methyl benzoic acid react with SOCl2. The Cl will substitute the functional group of hydroxyl and form acyl chloride. Structure P is an ester due to carboxylic acid react with alcohol with the presence of acid as catalyst. Therefore, the ester functional group will form at here. Treatment of 2-phenylethynolic acid with alcohol U give an ester V with molecular formula C11H14O2. Alcohol U react with alkaline iodine solution to form a yellow precipitate W, whereas oxidation of U yields X. Draw the structure for U, V, and X. Write all the chemical equation involved. Give IUPAC name of W. This is the structural formula of 2-phenylethanoic acid. From the structural formula, we know that the 2-phenylethanoic acid consists of 8 carbon. To produce an 11 carbon product, the alcohol U must be consists of 3 carbon atoms. And the second information is alcohol U react with alkaline iodine solution to form a yellow precipitate. This will give an information that alcohol U consists of methyl carbonyl group. Since alcohol U has 3 carbon, therefore this is a methyl group. Then this is a structure of alcohol U. The yellow precipitate of iodoform test, W is CHI3. Oxidation of U yield X. Therefore, the structural formula of X is a ketone and it is a propanone. So the answer for structural formula of U, V, and X are shown as below. These are all the chemical equation involved. Reaction between carboxylic acid with alcohol U to form ester. Alcohol U react with iodoform reagent and the chemical equation of oxidation of U form X. The IUPAC name of W is triiodormethane. Aromatic carboxylic acid can be formed from the oxidation of alkyl benzene, but in the condition to allow the oxidation reaction to occur in the alkyl benzene, the carbon bonded to the benzene ring must have at least one hydrogen attached to it. Then only oxidation process can occur. If the carbon attached to the benzene ring without any hydrogen attached to it, then there is no oxidation process occur. Methanoic acid is a special carboxylic acid that can undergo oxidation reaction to form carbon dioxide gas and water molecule. This is due to the methanoic acid has the aldehyde functional group. Then if it is oxidized by KMnO4 acidified hot, the observation will be brown precipitate form. If methanoic acid oxidized with Tollens reagent in basic medium, it will form carbon dioxide gas and water molecule with the observation which is silver mirror form. Methanoic acid is the only carboxylic acid that can react with Tollens reagent. Give your reasons, state the observation, and write the chemical equation involved. So the answer is methanoic acid has carbonyl functional group or aldehydic or aldehyde group. Thus, it shows reducing properties in the reaction with Tollens reagent. Observation is silver mirror form and the equation is as below. Another question, explain why methanoic acid give positive test toward Tollens reagent but ethanoic acid does not. Write the equation for the reaction. Reason is methanoic acid contain methanoyl group or CHO group or aldehyde group. Hence, it has reducing properties and or can be oxidized. The equation is as below. Thank you for watching.